Math 1314, Tyler Junior College, section 5.1, 2x2 linear system of equations, solving a 2x2 system by substitution, another example. In the previous video, I introduced how to solve a 2x2 system by substitution. These steps are still over here. We'll review them as we go through this example. But I also warned you that there's a problem that could arise. In the first step, we're going to solve for either variable in either equation, but the recommendation, if possible, choose a variable whose coefficient is 1 or -1. In this system, none of the coefficients are 1. My coefficients are 3, 2, 5, and -2. Now, why is that a problem? Because when we try to solve for either variable and create our substitution, if there's a coefficient in front of it, our last move is going to be to divide it away. If we were to try to solve for x in the first equation, my last move would be to divide everything by 3, but nothing else in the equation will divide by 3 cleanly. Same thing no matter which variable I pick. If I try to solve for the first y, my last move is to divide by 2, and nothing will. Same thing with the first x, nothing divides by 5, second x, nothing divides by 5, or second y, nothing divides by 2 evenly. So does that mean we can't use this technique? Of course not. It just means we have to be careful. Let's start with the first move, isolate any variable. Since none of them have a coefficient of 1 or -1, there's really no clear-cut winner here. So just pick one and go with it. Let's decide that for whatever reason you want to go with the second x. Why? Why not? If we were to solve this second equation for x, we would start by adding 2y to both sides. And that would give us 5x equals 2y plus 17. But to complete the substitution, or to complete the creation of the substitution, we would have to divide everything by 5, and nothing will. Dividing the left side by 5 gives us just an x. If we divided the right side by 5 by putting the entire binomial over a 5, we could split it into 2 fractions and say x equals 2/5 y plus 17/5. As inconvenient as that may seem, that is our substitution. And for full disclosure, at this point in your math career, you shouldn't be scared of fractions. You should just suck it up, take a deep breath, and jump in, because it's going to work out if you focus. Here's our substitution. X equals 2/5 y plus 17/5. We've done step 1. Step 2. Use the substitution to rename a variable in the other equation, use parentheses. Because our substitution says x equals, we're going to replace the x in the other equation with what it equals. So let's bring this first equation down here and replace the x with an empty set of parentheses. 3 parentheses plus 2y is equal to 7. Our substitution says I can replace the x and substitute it with 2/5 y plus 17/5. 2/5 y plus 17/5. The moves I'm going to make here are the same as I made in the previous video. It's just that they're being done with fractions instead of whole numbers. Distribute the 3. Think of it as 3 over 1 if that helps. 3 times 2/5 y is 6/5 y, plus 3 times 17/5 ends up being 51/5, plus 2y is equal to 7. At this point, you could combine the y's, but I'm going to go back to something that I said in a previous video, that if you're solving an equation with fractions, at some point you should consider getting rid of the fractions. Now, I know we can combine 6/5 and 2 by getting a common denominator, but what move could we do to the entire equation to wipe out every fraction that's currently in it? Answer, multiply by the least common denominator. The only denominator is 5. So, instead of combining fractions, I'm going to get rid of them. And if there's going to be fractions in the answer, so be it, but that can show up at the end. If we multiply everything by 5 right now and distribute, 5 times 6/5 would cancel the 5s. That would leave us a 6 in front of the y. 5 times 51/5, the 5s would cancel and leave us a 51. But here, 5 times positive 2y is positive 10y. And on the right side, 7 times 5 is 35. Doesn't get us closer to solving for y, but it makes it a little bit more palatable, if you will. Because now when I combine my like terms, 6y and 10y is 16y. Plus 51 is equal to 35. Subtract 51 from both sides. And we get 16y is equal to, I know this is negative, and the difference is exactly 16. So 16y is equal to negative 16. Divide both sides by 16, and we get y equals negative 1. Hooray, we have half our answer. And we need the other half. Substitute the known value into any equation to find the unknown value. We could substitute it in the substitution. You might stray away from it because it has fractions. I'm not going to. If we used our substitution, we would say x equals 2/5 times negative 1 plus 17/5. 2/5 times negative 1 is negative 2/5. So we have negative 2/5 plus 17/5. We're adding fractions, but they already have a common denominator of 5. So we can combine the numerators. Negative 2 plus 17 is 15. 15 over 5 is 3. Our ordered pair is 3, 1. And by the way, how to represent your solution depends upon your professor or your homework assignment. Some of them will want you to say x equals y equals. Some of them will want you to write the solution as an ordered pair. So the point of this example was to point out that asterisk is not always possible. You can't always choose a variable whose coefficient is 1 or negative 1. If that's the case, chances are your substitution is going to involve some fractions. Suck it up, run with it, and everything should be okay. It would be nice, though, if there were a way to solve this without having to wade through fractions any more than we had to. I don't want to seem like I'm speaking out of both sides of my mouth. On the one hand, you should be able to handle the fractions. You may not like it, but you should be able to handle it. But on the other hand, I'm always looking for the path that minimizes the opportunity for mistakes. And let's face it, the more fractions in a problem, the more opportunities to make a mistake. That's why I think doing something like multiplying by 5 right here to get rid of the fractions at the right time is a fine idea. Although you could solve the equation without doing that. In the next video, I'm going to show you how a different technique for solving a system that will probably bypass all fractions from the beginning until the end, unless they show up at the very end, in which case it's not a big deal. That's just the solution.